You subtracted half an x from both sides. Okay, we can go over that. So I'm going to subtract half an x. So that would give me 2/3 of an x minus half an x minus 4/3 is equal to negative 3/2. Okay. What did you end up with then on this side when you did that? Yeah.
1/6 of an x.
And how did you get that? Just for those that haven't quite got to that point.
You listen what half of 2/3 is. Then you multiply each. Well, you already multiplied.
Well, when you add or subtract fractions, anyone can jump in. What do we have to do? Well, we've done that bit, but when we want to do that, yeah,
What's the
common denominator, and the common denominator would be 6. So we've got this one times 2, so that would be 4/6, and this would be 3/6. So then we've got 4/6 of an x minus 3/6 of an x gives me 1/6 of an x. All right. So I've done the first stage. All right. Then what did you do?
added 4/3.
Yeah. So we've got. Yeah. Sorry, I've written it in the other order, but yeah. So add 4/3. So that gets rid of that, which is 1/6 of an x. And do we do the same thing here? So that would be negative 9/6 and 8/6. Sorry. Yeah. Good. Cool. Did anyone do it a different way? Or is that what everyone did? You did the same thing. Okay, I had a slightly different method myself, so I'm going to tell you what I did. Well, it's very similar, uses the same sort of idea, but maybe in a different order. So this is what I did. First of all, I put everything as the same common denominator right from the start. So I made this 4/6 of an x, and this was 8/6, and this was 3/6 of an x, and this was 9/6. So I did the common denominator bit straight away from the beginning. All right. Is that all right with everyone? Basically what you did before. I then did something else. I kind of recombined my fractions. So I wrote this as, instead of 4 divided by 6 and 8 divided by 6, I've got 4x subtract 8, all of that divided by 6. Does that make sense? A question requires communication and response. That makes sense. Okay, well, so what would I put on the other side then, if that makes sense? Yeah, good. All right. Now I would do what Aidan did last, which is multiply both sides by 6, which gives me 4x subtract 8. Okay. Which gets rid of the 6's now. And then I subtracted the 3x. and I added the 8, and that gave me 1x is equal to -1. So I did the same process. Really, it's the same sort of stuff, but maybe in a different order, but it gives us another way to do it. Okay. So those of you that were not quite sure, does that clear things up a little bit, maybe? Cool. Right. Unless anyone's got any questions, let's move on. All right, so this graphing activity 1. Now, do you remember last lesson I asked you to do activity 1 and activity 2? A lot of you only did 1, right? I kind of asked you to do 2 things, and a lot of you just did this, and that probably only took you 10 minutes, and you didn't have a look at the second one. You didn't give me it. So just saying that really you should have plenty of time. I'm not overloading you with work. So some of you were brilliant. You did whole pages full of work. You obviously put the effort in, so that's great, and you'll benefit. Some of you guys didn't. All right. So anyway, let's have a look quickly at this. So it's saying on the grid, draw the following lines. Now, so hopefully, what do you see on the screen now, guys? Still the same stuff? Okay. So here they are on Desmos. So I've graphed those 2. All right. They're the 2 lines that you've been asked to graph. What are we looking for again? The point where they intersect, and they intersect on Desmos. It tells you nicely that that's at 1 and -2. So what does that point mean again? Okay, and when you say it works for both equations, what do we mean by that? So we've got 1 and -2. So let's go back when it says, why do these lines intersect? Justify your answer. Let's talk about find the coordinates, verify that the point of intersection is on both lines by substituting the coordinates. What does that mean? So the coordinate we got, what was it? 1 and -2. So what does that mean? Okay, but what does it mean about with the 2 equations? Yeah, so for both of them, if I put 1 in for the x, all right, they both give me -2 for the y. Yeah, that's what it's telling me. All right. If I put any other value of x in, I do not get the same value of y out. But when I put x, so we can just check. So what is it? Y is -3x. What was 1? -3x plus 1 and 2x minus 4. Y equals 2x. What was it? -4? All right, so we've got 1 and 2, -2. So that means if we do -3 multiplied by 1 plus 1, I should get the answer -2. So that is -2, so that's good. And on this one, we've got y is 2 lots of 1 minus 4, so that's 2 minus 4, which is again -2. So they both give me the same thing. All right, so that's what we've already talked about before, so it's why it's quite quick. Can I just ask you guys, why do they intersect? Here's the question. Why do they intersect? What did you put? Different slopes. Okay. So what does that mean in any more detail? They're not parallel. Yeah. So it means that one is increasing or decreasing at a different rate than the other. We talked about this in a previous topic, and what it means is if they're the same at one point, they're never going to be the same again, are they? All right, because they change at different amounts. So because they're both straight lines, that's it. All right, they're never going to be the same again, only on one particular point. All right. So we've got these. Repeat steps 1 through 5 using the following equations. What did you notice? Did they cross as well? Yeah. So if I put the next two in, so what's the solution for these two? It's at 2 and -2. If I put the next pair in, all right, we've also got a solution at 2.5 -2. All right. So in all of those cases, we have one particular point that solves our equations. That's the one value of x and y that agrees in both. Right, but here's the sort of next step that we're talking about, and we have done it before. Again, what do you notice about the difference in the two equations here? Different form, yeah. All right. Does anyone other than Jack remember what those different forms are called? Yep, that's one, isn't it? So this one here, number 1, is in gradient and intercept form. And number 2 is in, anyone remember? Yeah, there you go. Standard form. All right. Okay, so we've got two different ways of graphing them, but they still produce a graph, and we can still check whether they cross or not and find the value of x and y. Right, so that's what we were looking at. And we're going to be looking at, well, you're going to look at which one's easiest to use. How do you want them to be when you're trying to solve the equations? Because we can obviously rewrite them, can't we? So that's what we're going to consider. All right. So I'm going to come back to this reflect and discuss in a minute and go on to this next one, which is the activity 2 that I asked you all to do. Okay, and it says revenue is the amount of money a company takes from sales of a product. Can you explain for me why we could write it as y equals 70x? What does that mean? How would that explain? Go on.
X is the number of products that we sold, and
Yeah.
70 is the price, and Y is the revenue.
Okay, so x is the number sold, 70 is the price per unit. Okay, and y is, sorry, what did you say? The revenue, yeah. So obviously the more I sell, all right, the more revenue I get. If I make the price higher, so let's say I make it 80, so it's 80x, what will happen to the line if I plot that? Yeah, it becomes steeper, doesn't it? Because obviously if I sell more at a higher rate, the revenue is going to go up quicker. All right. Right, what about the cost of making the hammocks is this? Right, so could you explain that, anyone?
When you buy today, X is the number of products sold,
Yeah.
and 500 is like the cost of the time to cut up, and the original cost that.
Well, actually, X in this case, we wouldn't necessarily say the number sold, but maybe the number that we've made. Yeah. So hopefully we're going to make everything that we sell. But yeah, it's the number of hammocks, whether it's how many I've sold or whether it's the number I've made. Yeah. So it cost me 25 whatever dollars to make a hammock. So did you tell me what the plus 500 is? Okay, so have you ever heard this guy's called a fixed cost? Yeah, no? Have you done anything like that in INS business? So a fixed cost, you'll notice there's no X on it, which means it will never change. So it's got nothing to do with how many I make. All right. So basically that would be the cost of renting the business, the renting the place I'm making it, it'd be the cost of the materials that I have to buy, or it'd just be something that's fixed that will never change. Maybe it's the amount of money that I'm going to pay myself. Right? I'm always going to pay myself 500 regardless. So it's what's called a fixed cost. All right, so we're going to solve them by graphing, which I've already got ready for us. All right, so here we go. We've got these two. And right, I can't see anything, guys. So I'm going to set my axes. Tell me what to set them as. So what do I set my X as? $70. All right. What about the lowest end? What's the least amount of hammocks I can have or make or sell? 0. Yeah, let's do 0. Okay, what about the Y? What should we go up to? It's a bit trial and error now. Remember, it's 70 every hammock. So it's going to be a big number, isn't it? Should we try maybe 5,000? There you go. There's a good guess. 5,000. Right. So blue line is Y equals 70x. And the green line is 25x plus 500. So can you explain to me what's happening on my screen? What are those two lines showing me? Okay, so oh, have I got some chats? Adriana, yeah, Jasmine said break even point. Adriana, what's the blue line? Is that income or outgoings? That's your income. Good. So that's starting at 0, look, and your money going up. But we had a fixed cost here of 500. So at the beginning, I'm 500 in debt, but my debt goes up slowly, but my income goes up quicker. So there is a point at which they cross, okay, and that's called my break-even point. And at that point, I can start making money. So how many hammocks do I need to sell before I can make money? Cameron, how many do I need to sell before I can make money? 12, good. All right, because it's a little bit over 11. So if I sell 11, I'm still a little bit in debt, and I can't sell 11.1 hammocks. I would have to sell 12, okay? And after that point, it goes up. So this is the problem businesses face. If their costs per hammock go up, for instance, all right, so let's say it's 50x plus 500, it takes me longer to break even. Okay, if it goes up, right? If my costs per hammock are the same as what I'm selling them for. Okay. And some companies will even say that they sell at a loss. All right. For whatever reason. All right. But in this case with Hammocks, we can make them for less than I sell them, so I will eventually make money. All right. But does anyone have any ideas about a potential problem with that? Yeah. So I'm assuming that I'm going to sell them all. So we're kind of saying to, oh, all I need to do is sell 12 and I get some money. So I'm just going to plan to sell 40 and then I make a load of money. But what if you can't sell 40? All right. So suddenly your costs go up because you've made 40. So these will be your cost. But let's say your blue line stops down here and doesn't go any further because you don't actually sell anymore. So there are other factors to look into. Right, what I'm interested in then is these two equations that we've got are in what form? Charlie, what form are they written in? Well, we said two options before. We said gradient intercept or standard. Gradient and intercept. And what does the gradient tell me? Which numbers are the gradient values in those two equations? The 25 and the 70. Good. So that's how much is going up by. So this is a really nice form, guys, for drawing lines like this. We can interpret it really well. That's easily the fixed cost. This is our rate at which I'm making money or losing money. So that's what we're talking about. So going back to the other screen, all right? So I want to look at these three. We've literally got a couple of minutes. Those three there, they are not written in gradient intercept form, but we want to be able to write them in gradient intercept form because it makes it easier to put them into, to understand what's happening. Okay, so looking at those three, what do you think, guys? Are you able to use your skills that you've got from solving your equations to write those in gradient intercept form? What do we think? Yeah. Jack, could you give us a clue? What would be what would the thought process be? Not too much because we've only got a couple of minutes, but if you had to sum it all up in like one sentence, what would you do? No? All right.
Just y isolated on one side
Yeah.
of the equation, and on the other side I would have some quantity of x and a value for the y-intercept.
Yeah. So this is what your next stage is, guys, and we have already done this one before, so you're kind of just practicing, but you're using the same sort of skills that you had before and what you've just been using, and you are going to look at these and try and eliminate them down so that you've got one y on one side and everything else on the other. So for instance, on this one, it's nice and simple. I'm just going to divide by 2 because I've got 2 y's, but I only want 1. So what do I do on the other side? So I've got negative 4x plus 8 all divided by 2. Does that simplify 2 at all? Can I divide it all by 2? Yes, I can. Negative 4x's divided by 2 is negative 2x's. 8 divided by 2 is 4. So there's my gradient and intercept form. All right. Make sense? Okay. This one here, let me just go through it quickly. So I would do this one as, I'm going to add my 10 y's because I don't want negative y's. So I'm going to have 5x and 20 plus 10y. I'm then going to subtract the 20. All right, you might say this is a long-winded way, but that's fine. And then I'm going to divide by the 10. Okay, and that gives me 5x minus 20 divided by 10 is equal to y. Now, does this side divide by 10? So for instance, 5x divided by 10, 20 divided by 10 is 2, yeah? What about the 5x divided by 10? What would you change that to? Yeah, 0.5x or half an x, yeah. Half an x minus 2 is y. So just before we finish, does it matter that the y is on the right-hand side, not the left-hand side? No, it doesn't. Because that equal sign just means both sides are equal. Okay, sorry, that was a bit of a quick way through. I've videoed it, so I'll put it up there. I'm going to be asking you to finish off this one and then do some more tomorrow, get through a few more. I think maybe setting my minimum target needs to be upped, because if I say do at least 2, most of you do 2 and that's it. All right, so I'm going to maybe set a little bit more. If you need help, let me know. But as time is about to run out, if you need any more help with any of that,